So, did you try these before you found this answer key video? Let's see if you agree. By the way, if you got number 1, then fast forward to number 2. And if you got 1 and 2, fast forward to 3. You don't have to watch the whole video to get to the problem you need to see. Fast forward. Okay, so let's look at number 1. Directions were the same as the lecture. Write each trigonometric expression as an algebraic expression in the variable u. So, do you remember how I started the lecture? Yeah, I looked at the parentheses, because the parentheses is where the order of operations always start. So first, I'm looking at the cosine inverse of u. And since it's inverse, I know that that's theta, right? Which tells me that here, I'm literally looking for the sine of theta. Does that make sense? Okay. I personally don't want to deal with cosine inverse. I want just cosine. So I'm going to take the cosine of both sides to cancel this guy out. So I have u equals cosine of theta. And I'm just going to rewrite the order. Now remember, cosine comes from a right triangle, doesn't it? And cosine is adjacent over hypotenuse, which means I need that fraction because I need an adjacent and a hypotenuse on the right triangle. So if I draw the right triangle and I put theta in, again, remember I said I always write theta here. If you want to write it here, that's fine. So adjacent over hypotenuse. Okay. So I have 2 out of the 3 sides of this triangle verified or established. But the problem wants me to find sine of theta. And sine of theta deals with the opposite side. This wants the opposite over the hypotenuse. Well, I guess I need to find the opposite side, don't I? Gratefully, it's a right triangle. How are you going to find the opposite side? Pythagorean's theorem. So if you don't mind, I shall just call it y squared plus u squared equals 1. And y squared is this. Y is that side. So that means y squared equals 1 minus u squared. And I'm going to take the square root of both sides, and I'm supposed to get 2 answers, one positive, one negative. Agreed? However, it didn't tell me what quadrant I was in, so I'm going to assume it to be positive, which means this side is simply 1 minus u squared, which means when I find the sine of theta is going to be equal to opposite 1 minus u squared over hypotenuse, which is simply 1. That is this algebraic expression. Good? Makes sense? Excellent. Okay, let's look at problem number 2. How are we starting if you haven't started it? You're going to start with the parentheses. So the first thing you're going to look at is the cosecant inverse of u. And cosecant inverse means, yeah, you're looking for the angle, which means I am actually looking for the tangent of theta. Tangent is opposite over adjacent. So I'm going to need a triangle, aren't I? So same steps, right? Cosecant of theta. But what's cosecant? Yeah, cosecant's the reciprocal of sine, right? So if I remember that, isn't 1 over u equal then to the sine of theta? Right? Because it's the reciprocal. Right triangle needed? Put my theta here. And you can stay with cosecant. You don't have to put sine. Because if this is the reciprocal, that means a cosecant is the hypotenuse over the opposite. It's the same thing. Opposite, hypotenuse. Same thing. Good? Okay, and now I need tangent. Tangent is opposite over adjacent. Nuts, I need the adjacent side. All right, how do I find it? Okay, I'm going to call this x. So here we go with Pythagorean theorem again. 1 squared plus x squared equals u. X squared, u squared, excuse me. U squared minus 1, right? Oops, I forgot to put a square on that, didn't I? Well, gratefully it was a 1. And then x is going to be equal to the square root of u squared minus 1. So that is my adjacent side to theta. Okay with that? Okay. So tangent is opposite over adjacent. And can't leave the radical in the denominator, so I'm rationalizing it. And I'm hoping you remember how to rationalize. And here is the algebraic expression for the original problem. Good? Okay. I've got 2 more problems coming your way. And if you need to review these first, and then come find me on the last 2 problems. Okay, did you try these 2? Not too bad, right? And if you're like, I didn't try them, well, then let's work on it. Sorry, I realized that I goofed on something. This should be find the sine of theta, not just theta. Okay, so the directions were write an algebraic expression in terms of u. Well, looks like the variable u went by the wayside, but I'm going to write an algebraic expression based upon the variables that they've given me in each problem. Okay? It's the same concept, just a different variable. But let's look at problem 3. So they gave me the tangent of theta and they want me to find the sine of theta. Got it. The great thing is they gave me the tangent of theta. So if I know the tangent of theta, then I can actually construct a what? Excellent, a right triangle. Because tangent is found from a right triangle. And again, me personally, I always put theta in the bottom corner. So, how do you find tangent? Opposite over adjacent, which means x is opposite and 2 is adjacent. Now they want me to find the sine of theta. How do you find sine? Sine is opposite over hypotenuse, right? I'm missing the hypotenuse. Know what you got to do? Pythagorean theorem. Your best friend in trig is Pythagorean theorem. So, to find the hypotenuse, I'm going to do x squared plus 2 squared equals r squared. R is going to be my hypotenuse. So, x squared plus 4 is r squared. And hypotenuse is always positive, so x squared plus 4 is now my hypotenuse. Good? Okay. So then, can I find the sine of theta? Therefore, 3 dots in a triangle mean therefore. The sine of theta equals opposite over hypotenuse. Not allowed to leave the radical down there. So the sine of theta equals, and again, I'm assuming you remember how to rationalize. Good? Lovely. Problem 4. What do you think? I heard you make a right triangle based on you knowing cosine. All right, here we go. So here's my right triangle based upon me knowing cosine. How do I find cosine? Adjacent over hypotenuse. They want me to find cotangent. How do you find cotangent? Adjacent. Whoops. How about I try that again? How do you find cotangent? Adjacent over opposite. We're missing a side. Was that any surprise to you that we'd be missing a side? I know it wasn't to me. Okay, so I'm just going to call this y. So to find it, good, I heard you. Y squared plus r squared equals t squared. Remember, you're solving for y. So y squared equals t squared minus r squared. So y equals the square root of t squared minus r squared. T squared minus r squared. All right, are we ready to find cotangent? So then, therefore, the cotangent of theta. How do you find cotangent? Adjacent over opposite. Wouldn't you know the radical would be in the bottom? You know what to do. What'd you get? R times the square root of t squared minus r squared all over t squared minus r squared. These algebraic expressions can look very interesting, but there they are, and so be it. If that's what they want, that's what they get. So there's a little bit of an advantage because t and r can be any numbers, and all I would have to do would be to plug in those numbers to literally find what the cotangent of theta was. So it's kind of an advantage. But good, it's the same process we know to do. Get our right triangles established, find the missing side using Pythagorean's theorem, and then remember how I find, in this case, cotangent, or in this case, sine. All right, have fun. Catch you on the flip side.